Example 1. So a farmer is planning to fence a rectangular pasture adjacent to a river with no fencing required along the river. The pasture must contain 180,000 square miles to provide enough grazing land for the animals. So we want to know what dimensions require the least amount of fencing. So our first step we want to do is we want to draw a picture and label it with variables. So I'm going to call this pic var. And so if we think about it, here's our river. We don't need any fencing there, but then we just want a rectangular pasture. So these two sides of the fence will be the same. We can just call them X, and this other side is Y. So what do we know now? So in this case, we know the pasture must contain 180,000 square miles. So in this case, to find area, we know it's length times width, so X times Y. Call that area. So A equals X times Y equals 180,000 square miles. So remember, area units are always going to be square units. And we know in this case, X and Y are both greater than 0. What do we want to find out? So in this case, we want to know the dimensions, so X and Y, such that the perimeter is minimized. So we want the least amount of fencing. So the least amount of fencing goes around the outside of our enclosed area. So that's going to be perimeter. So we want X and Y such that perimeter is minimized. So the next thing we want to find out is we need to know what function we're going to be working with and its domain. So we want our function to be related to what we want. So in this case, we want the dimensions such that the perimeter is minimized. So we need our function to be the perimeter function. So we know in this case, perimeter of a rectangle is 2x plus 1y, since we don't need fencing on our river. But the issue with this is now this function is in two variables. It's in terms of both x and y. So we need to make it a function of one variable. So to do that, we're going to use what we know. So in this case, we know x times y is 180,000 square miles. So we want to essentially solve this for one variable. So let's solve for y. So we know in this case, y is 180,000 divided by x. So then that gives us a function p of x for our perimeter function is equal to 2x plus 180,000 over x. That's going to be our perimeter function in terms of one variable x. So we've got our function. So now we need to be able to figure out the domain of this function. So we know x and y are both have to be positive, since we're talking about sides of a fence, dimensions. So since both x and y are positive, well, we know if x is positive, then y is 180,000 divided by x. So that's going to be positive as well, if x is positive. So in this case, we know then our domain is just going to be, for this function, is going to be x greater than 0. So in other words, writing this in interval notation, our domain is 0 to infinity. So there's our function. Our function's p of x equals 2x plus 180,000 over x. Our domain is 0 to infinity. Now you're probably asking, why do we need to worry about finding the domain? Well, remember, the domain helps you out because you know if your answer is a valid answer or not, number one, but also it can help you eliminate critical numbers. If you get a critical number that's not in the domain, you don't have to test that critical number in the next step. So our next step is to find the critical numbers and to test them. So to do that, so we know in this case p of x was 2x plus 180,000 over x whenever x is on the interval 0 to infinity. So then to find the critical numbers, find our derivative. So p prime of x is 2 minus 180,000 over x squared. Again, at this point, you should be comfortable finding derivatives. And we're going to set that equal to 0 and find all values where it's undefined. So in this case, 2 equals 180,000 over x squared. So 2x squared equals 180,000. Divide by 2 on both sides. So we get x squared equals 9,000. Or sorry, 9. Yeah, we get 9,000. So then x is equal to plus or minus. So square root of that equals the plus or negative square root of 9,000. So x equals plus or minus 300. Now in this case, so we have two critical numbers, but because x has to be on the interval 0 to infinity, x has to be greater than 0, then we don't need to worry about testing this negative piece. So the only critical number we have to test in this case is x equals positive 300. Now, think about where it's undefined. So that's where we set it equal to 0. Where's it going to be undefined at? Whenever x equals 0, right? But we don't have to test that. Why not? It's not a critical number because it's not in the domain of our function, right? So the only critical number we have to test is 300. So now do our test. So let's do the second derivative test first. I always recommend trying the second derivative test before you try to use the first derivative test. Just because second derivative test, if it works, is going to be easier. So p double prime of x is equal to 360,000 over x cubed. So p double prime of 300 is 360,000 divided by 300 cubed. And that's certainly going to be greater than 0 because 300 is positive. So 300 to the third power is going to be positive. And a positive divided by a positive is going to be positive. So we know our second derivative evaluated at 300 is greater than 0. So then that tells us by the second derivative test, so p double prime, so p of x, so our function, has a relative minimum whenever x equals 300. So now the answer, so that's always our last step, is to answer the question. So in this case, the dimensions that will minimize perimeter are x equals 300, and don't forget your units here, so x equals 300 miles, and y is equal to 180,000 divided by 300, which is equal to 900 miles. So make sure you remember your units. If you forget your units, you will lose points on these questions.